Hello everybody, this is the chi-square problem review from participation sheet for week 9. I'm going to go through the answer now. Hopefully you've already had a chance to do this. All of this is practice leading up to our exam number 2, so as you already know, it's going to cover quite a bit about chi-square in addition to normal distributions and hypothesis testing. So let's go ahead and go straight into our fact pattern. A social work chooses to study whether an association can be found between unemployment and depression. To conduct this study, she creates a survey that asks for respondents' employment status and whether they have experienced symptoms for depression. Okay, and in this case, depression is going to be defined by the DSM-5. Okay, here are the results. Of those who identified as unemployed, 13 found they experienced symptoms of depression, while 7 declared they did not. Of those who identified as employed, 5 found they experienced symptoms of depression, while 10 did not. Of course, leaving some space for us, I always want to make sure we begin with the null hypothesis to realize that this is what we're ultimately testing. The first 3 words of any null hypothesis are always the same. There, let me just go ahead and take that off. There is no. Okay. And in this particular case, we're looking at 2 variables. One is employment status. So we're going to say there is no association between employment status and depression. Now, notice that with the variable employment status, you can have 2 attributes, unemployed or employed. Just as with the variable depression, you have 2 attributes, depressed or not depressed. And that helps us kind of figure out how we're going to write the next part. Okay, observed values. There you go. Whoops, I'll spell that correctly for you. All right, observed values. Okay, and we're going to go ahead, and I usually just do this one first. I'm going to go ahead and say we're going to have unemployed as a variable here, as an attribute of the variable here, employed down here. Okay, we'll have total right here. Okay, likewise, with depression, we'll say depressed, we'll say not depressed. Okay, there we go, and finally total. All right, so with respect to the observed values, we can start filling these out pretty rapidly. We have, for unemployed, those who are depressed, we have unemployed who are depressed at 13. So unemployed, depressed, we'll just go ahead and put the 13 in. Okay, unemployed as a category, not depressed. Okay, I'll just show you where I have this, 7. So we'll go ahead and put that there. And then if we go across, 13 plus 7 equals 20. Okay, coming on down to employed. Okay, we found that 5, those who were employed, experienced symptoms of depression, while 10 did not. So we'll go ahead and come across again, and we'll have 15. Now if I take the not depressed column and total it, I have 17. And if I do the same with the depressed column, I have 18. Okay, so in this particular case, n equals 35. Okay, 20 plus 15 is 35, just as 18 plus 17 is 35. Therefore, we have the accurate count. I'm going to go ahead and copy this cross tabulation, and I'm going to come down here and I'm going to change the nomenclature from observed to expected values. And I'm just going to go ahead and take out the center values here because we need to find the expected values. And the way we do this is by looking at the ends for each cell. So the end for the cell unemployed and depressed, we go down and we see we have an 18. Oops, 18. And then if we come across, we see we have 20. Okay. And if you were doing this math-wise, you might say that we have, well, if we just forget about that 0 for a second, we'd say 18 times 2, which is 36. And if we bring that 0 back, we'd say 360. Okay, and then we take 360 divided by n, which in this case is 35. Okay, and what do we have here? Well, just to be absolutely sure, because we're dividing an even number by an odd number, I'm just going to go ahead and do this. 360 divided by 35. Okay, and what we'll do is we'll say 10.29 because we'll just round up that digit in the hundredths place. So 10.29. Okay, 10.29. Okay, great deal. Okay, now let's go ahead and take a look at what we have over here. Okay, coming down here we have 17, okay, times 20. We do 17 times 20. We're going to have 34, and then we add that 0 in, so it'd be 340, okay, 340, and we'll say 340 divided by 35. It's going to give us what number? Well, let's take a look at that. Okay, bringing back the calculator, we'll say 340 divided by 35, 9.71. Why? Because if we round that 1, yeah, this is lower than 5, so we'll just keep it at 9.71. Okay. All right. Now we're moving right along, and really these are not hard variables to work with at all, very easy numbers. Okay, for the cell, whoops, I'm going to come down to the C cell. I like to go A, B, C. Okay, let's take a look at the value for this cell. We have 17 times 15, because of course that's the other value here. And we'll just go ahead and use our trusty calculator just to make things simple. Okay, 17 times 15 equals 255. Okay, 255 will come down to 55 divided by 35. Okay, what's that equal? Well, let's find out. 255 divided by 35. So I guess I could have kept that. Divided by 35. All right, we have 7.29. 7.29. You see I rounded up. 7.29. There you go. And finally, we're going to go ahead and come to our final cell. I call this the D cell. We'll say 18 times 15 equals, okay, all right, 18 times 15. Okay, 270. Okay, so just to be absolutely clear with everybody, we'll go 270 here. Bring 270 down, divide it by 35. Okay, 35 is our in. When we do, here's what we're going to get. Okay, 270 divided by 35. Okay, 7.71. 7.71. Okay, 7.71. Okay, terrific. We have all of our expected values. We really didn't take that much time to get them. I mean, we saw the process, which is the most important part, because that's what we're going to use each time we attack a new fact pattern. The numbers are always going to be different, so just knowing the process is half the battle. Okay, when I go ahead and clean this up, it looks nicer for us. Okay, maybe I can just do that too. There we go. All right, so now what's up? What did we do here? We're going to go chi. Okay, I showed you how to do this before. Superscript, okay, squared. Okay, will come off of that. Okay, equals, okay, and remember you can also find the sigma right here, sigma there. Okay, and we're going to have the observed value for each cell minus the expected value for each cell. Okay, of course that's going to be squared. So this is squared. And then after that, okay, after we square it, we're going to divide it again by the expected value. There you go. Actually, we'll give it a capital E. It deserves it, right? Okay, let's take a look at the A cell. It's the one I usually start with right here. A, B, C, D. I go clockwise. Okay, what's our observed value? 13. Okay, what is our expected value? 10.29. Okay, and we're going to end up squaring this. So just for the fun of it, we'll go ahead and make sure we remember to do that. Otherwise, you get a little bit lost, and that's not what we're trying to do here. Okay, divided by 10.29. Okay, that's going to give us the value. So when we come down here, here's what I'm going to do for you. I'm going to do it all in one fell swoop since you've been doing this for a while now. We'll go 13 minus 10.29. Okay, we're going to get 2.71. And if I was to go ahead and square that, okay, 7.34. Okay, 7.34. 7.34. Okay, it's after I squared it. Actually, you know what? I can take off these parentheses because what I'm going to do now is I'm going to come down here and I'm going to give the denominator as 10.29 because that's our expected value. And I can already just take a look at this number and see it's going to be a decimal. it's going to be lower than, it's going to be under 1. So let's just go ahead and find it. Okay, 7.34. I'll get it absolutely clear. Okay, divided by 10.29. What's that going to give us? Okay. Well, I knew it would be under 1, 0.71. Okay, so let's go ahead and knock this down. We'll say 0.71. Okay, moving on to the B cell. Okay, B cell is 7. It's going to be observed. Okay, and then we'll go ahead and say 9.71. Okay, and it's going to be squared. In fact, what I can do right here, if I'm just trying to be, I'll just copy and paste that. So I'll go down here, and then of course I need to copy and paste that. So that's going to be different, but it saves me a little bit of time, don't you think? Okay. All right. So let's say what we have here. We have 7. Go ahead and pull up the calculator. Okay, 7 subtract 9.71. Okay, there it is. Negative number, yes. Okay, now we saw that one before. We already know what it's going to be, but we'll go ahead and square it. And when we do, here's what you're going to find. Same as before, 7.34. 0.34. Okay, and 7. Whoops, we'll go ahead and do it this way, just to not be confused. 7.34. Okay, divided by 9.71. So let's see if we can get this nice and clean. Okay, 7.34 divided by 9.71. I already know it's going to be a decimal. Okay, 0.76. Actually, we'll just go like this. 0.76, because that's just rounded up right there. Okay, all right. 0.76. Very good. Okay, let's take a look at what we have for the C cell. C cell's right here. Okay, C cell's right here. Okay, observe value. You know what I'm going to do? Just to save us a lot of time, just gonna copy this down. Okay, do it this way, and we're gonna go like this. Okay, what value am I gonna put here? 10 minus, and what did we say this is? Okay, actually it's right here. 7.29. Okay. We obviously know that this is going to be the expected value, so that's what we're going to divide by as well. There we go. Okay, so I'm going to go ahead and get all this out because we haven't done it yet. Okay, and we'll go back to my calculator. Okay, we'll say 10 subtract 7.29. There it is. Okay, what do you think it was going to be? Of course we know what it was going to be. Okay, we square it. We've seen this before. Okay, 7.34 divided by 7.29. All right, so what we got here. I think it's going to be, okay, what's it going to be? Okay, 7.34 divided by 7.29. I think it's going to be a little over 1. What do you think? Yep. It's going to be 1.01. Okay, guess we had that one pegged. All right, and last one. I'll go ahead and do the same thing I've been doing just because it seems to be nice and convenient for us. Okay, if I go ahead and do it that way, get rid of that. Okay, and let's take a look at our last one. Okay, the observed value is going to be 5. Okay, and the expected value is going to be 7.71. I got that right here. Okay, and we're going to get rid of this, 7.71. Okay, I'm going to go ahead and get rid of that so it's just nice and clean. And we'll go like this. Clear. 5 minus 7.71 equals what? I bet I know. Oh, same as we saw before. Okay, 7.34. Yeah, except we're going to have a different denominator because we changed. Okay, it's going to be 7.71. I'm guessing this is under 1. I'm guessing this is under 1 because we didn't quite get the numerator to be at or greater than the denominator. So let's go ahead and see what we found. I'm betting it's under 1. Okay, so 7.34 divided by 7.71 gives us a cool, okay, yep, just what I thought, 0.95. Okay, 0.95. Okay, so we will go ahead then, and I like to highlight these, just makes it a little bit easier because you know what our book says and what our equation tells us is what we're going to end up having to do is not just sit there and look at these numbers and be happy with them. We're going to have to add them up because, of course, we have a sigma here. So what am I going to have this look like? We can still see them from here. Okay, so we're going to actually go like this. Okay, I'm going to borrow this chi-square right here. I'm going to come down here and I'm going to say calculated chi-square equals, and I have to go 0.71 plus 0.76 plus, ooh, that actually got kind of small, didn't it? Let's try that again. Sorry about that. Okay, let me get rid of that. Okay, yeah, much better, much better. 0.71 plus 0.76 plus 1.01 plus, okay, 0.95. Okay, and we'll go ahead and run the calculation on that. Okay, and the calculation on that will be 0.71 plus 0.76 plus 1.01 plus 0.95, 3.43. Okay, 3.43. Okay, oops. So we have our calculated value now, and our calculated value will sit here. And now we got to ask ourselves a new question. Since we have the calculated, we have to compare the calculated to the critical. And the way to find that is to go ahead, and I'm just going to go ahead and recall how I do this, right? So the way to find the critical value, we have to start with the degrees. Whoops. I'll just go ahead and degrees of freedom, okay, or df, okay, and that equals, okay, number of columns minus 1 times number of rows minus 1, okay, and we're not doing titles and totals here, okay, so if we take a look up here, number of columns we have, okay, we have one column here, here's a total, here's a title, we don't need that, so we just have 2 right here. So for columns, we're just going to go ahead and we're going to say columns, how many do we have? 2, that's minus 1, okay, times, and how many rows do we have, not accounting for titles and totals. So we have a row right here, total right here, title right there. We only have 2. Okay, so we'll say 2 minus 1. Okay, pretty easy numbers to deal with. Okay, so it's 1 times 1. There you go. Okay, which gives us 1. Okay, so when we're talking about what to do next, you're going to go, okay, find chart on page 69 of our text. And we have a degree of freedom of 1. You're going to move your finger, okay, down to the degree of freedom, and then we're going to find chart on page on page 69 of text. Okay, move to DF1, which is just basically moving your finger down from the DF to the 1 spot down. Okay, then move to, do you remember what it was? 0.05 column. Why? Because that's the APA default, and I already know this. Okay, the value you're going to find down there is going to be, I'm just going to go like this. I'm doing a lot of borrowing today. Okay, we'll go like this. Critical value. Okay, we'll go ahead and make sure we don't make everything shrinky dink. Okay. Okay. What's the critical value? Well, if I did my math correction, I'm sorry, if we did our math calculations correctly, it's going to be 3.84. Okay. Now you can see that we're kind of close here, and you can see why. Okay, I'm going to come over here and I'm going to say calculated. Okay, oops, calculated. Okay, calculated chi-square. Guess I could have just taken the whole thing, huh? All right, calculated chi-square, and then once I make it big again, okay, I'm going to go over here. Whoops, I guess I need to come back down first. Okay, there we go. And then I'm just going to go like this. And when I do, I print it out, or make them both bold-faced. Okay, heck, let's just go all out, right? Okay. All right. All right, so we have the calculated value in this case. Okay, and the calculated value in this case is going to be 3.43. Okay, and then our critical value over here is going to be 3.84. What's bigger? Well, we can see what is bigger. Okay, let's see. What we see is bigger is going to be, okay, oops, hold on a second here. Obviously, this critical value is going to be bigger. So what do we do here? Well, I have a way for you to sort through this. Let's go back up to the null hypothesis and cut and paste it. We'll copy and paste it, okay? All right, so we'll go ahead and say we reject, okay? When do we reject? We reject null, okay? When the calculated is greater than the critical value, okay? And we will accept, oops, I'll make it big, null, when the critical value is greater, oops, than the calculated value. Okay, so let's go ahead and take a look at our null hypothesis here, which I already queued up for you. Okay, reject, accept. Well, what do we have to do with this thing? We know that the critical value is greater than the calculated because the value we found on the chart, 3.84, is greater than the calculated value we did with the math, 3.43. So what are we going to do? We're going to actually accept this. Okay, we're going to accept the null hypothesis because we do that when the critical value is greater than the calculated value, which it is here. Okay, so that's what we're going to do. So when we accept it, we don't make any changes to the null hypothesis. We just say, yep, we accept that's true. So there is no association between employment status and depression. And that is how you solve this particular chi-square. Hope that was helpful. And hopefully by now you're getting all the processes down you need to have for our exam number 2.